Hello, this is Ravina More. First of all, welcome in third semester. I hope you are all well and I am going to teach you a concrete technology subject. If you have any query, you can ask me on WhatsApp group. Before moving towards topic, we should know about teaching and examination scheme of this subject. The semester is third and the academic year is 2020-21. The program name is Civil and Rural Engineering. Program code CR. Course Concrete Technology and its abbreviation is CTE. And the course code is 22305. Then examination scheme. In examination scheme there are two parts. First is theory and second part is practical. In first theory part, the theory contains total 100 marks. TH plus THP. TH, that is theory, end semester exam contains, that is your written paper, which contains 70 marks, and remaining 30 marks for THP, that is for your progressive assessment, in which 20 marks for test and 10 marks for your micro project. Then second part is practical. It totally contains 50 marks, in which 25 marks for your progressive assessment and that is for experiments, and remaining 25 marks for your external oral examination. There are 6 units in this chapter. The first unit is a cement, second is aggregate, third is concrete, fourth is concrete mix design and testing of concrete, fifth is quality control of concrete, and sixth chemical admixture in concrete, special concrete, and extreme weather concreting. Then course outcome. Then what is course outcome? It means the narrower statements that describe what students are expected to know and be able to do at the end of each courses. म्हणजेच मुलांना काय माहीत असणं अपेक्षित आहे आणि ते नॉलेज घेतल्यानंतर ते प्रॅक्टिकली इम्प्लिमेंट करण्यासाठी ते सक्षम होतील. थोडक्यात एखादं चॅप्टर किंवा टॉपिक शिकवण्याचा उद्देश काय. The course outcome for every chapter are given. Let's see. The first chapter is cement and its course outcome is use relevant type of cement in different site conditions. The second chapter is aggregate and its course outcome is use relevant aggregate for required concrete works. The third chapter is concrete and its course outcome is prepare concrete of desired compressive strength. The fourth, concrete mix design and testing of concrete, and its course outcome is prepare concrete of required specification. Fifth is quality control of concrete, and its course outcome is maintain quality of concrete. And sixth is chemical admixture in concrete, special concrete, and extreme weather concreting, and its course outcome is use relevant admixture for concreting for different weather conditions. Then move towards our topic, and the first chapter is cement. First point is introduction to cement. Cement means any substance that acts as a binding agent for different materials. That is, cement is a binding material. Then why it is important than any other building materials used in construction? Because cement is an extremely ground material having adhesive and cohesive property and provides very strong bond as compared to other binding materials. When cement is mixed with water, it forms a paste which hardens and binds the aggregate together to form a hard durable mass is called as a concrete. The cement gives strength to the concrete. Thus, cement is one of the important ingredients of concrete. The next point is history. The history of cementing material is old as history of engineering construction. when humans got knowledge about construction of shelters. From that time to till date, various cementing materials are discovered and modified too. Some kind of cementing materials were used by Egyptians, Romans, and Indians in their ancient construction, such as construction of cities of Harappa and Mohenjo-daro and pyramids. The cementing material is obtained by burning gypsum, means plaster of Paris, by burning limestone, means chunkhadi, and after they are aware about volcanic ash, the ash which is come out after volcanic eruption, and tuff means porous stone which is also come out from volcanic eruption. After that, the cement starts modifying according to requirements and conditions. Then we will see further history of cement.
Introduction to cement. This video deals with the cement and its history. Cement is one of the most important building material which binds the materials together. Cement is the mixture of lime, silica, alumina, iron oxide, and magnesium oxide. These are used with fine aggregate to produce mortar or with coarse aggregate and fine aggregate to produce concrete. The history of cement was in the year 1756. John Smeaton demonstrates, hydraulic lime can resist the action of water which can be obtained from the hard lime. In 1796, Joseph Parker shows that hydraulic cement made from the burning of argillaceous limestone, which was led to the invention of Portland cement. Portland cement is the most common type of cement in general use today. The cement which we use today was discovered by Joseph Aspin, a British stonemason, in the year 1824. He was trying to fire the mix of finely ground limestone and clay with water in his kitchen. After a while, he noticed that the mixture was set and hard. He found that it was cement which bonded and hardens the mixture. As he considered his cement resembles the Jurassic Portland stone of Dorset, England, he named the cement as Portland cement. The first engineering structure made of cement was Thames River Tunnel. Nowadays, cement is used for many fields. They are: cement mortar is used for masonry work, plaster, pointing, etc. Cement concrete is used for the construction of various structures such as buildings, bridges, water tanks, tunnels, etc. Also, cement is used for lamp posts, telephone posts, railway sleepers, etc.
The next point is manufacturing process of cement. Then let's see how cement is manufactured. The raw materials used for manufacture of Portland cement are calcareous and argillaceous materials. Calcareous material means the material which contains calcium, and argillaceous material means the material which contains clay. In calcareous material, limestone, chalk includes, and in argillaceous material, shale and clay. The process of manufacture of cement consists of grinding the raw materials into a jaw crusher, then crushed material is stored into a storage bins. According to type of cement, mixing them intimately in a certain proportions. After that, material is sent to a rotary kiln. Rotary kiln means furnace or bhatti. Then burning them in a kiln at a temperature of about 1300 degrees Celsius to 1500 degrees Celsius, at which the material sinters and fuses to form a nodular shaped clinker. Because of high temperature, material melts down and converted into a small rounded lumps. Then the clinker is cooled under controlled condition and ground to a fine powder with addition of about 2 to 3% of gypsum. The product formed by using this procedure is called as a Portland cement. There are two processes known as wet and dry processes depending upon whether the mixing and grinding of raw materials is done in wet or dry condition. The dry process of manufacturing of cement. Then let's see how cement is manufactured according to dry process. In dry process, the raw materials that is calcareous and argillaceous materials are crushed and fed into right proportions and grinding them in a ball mill where they are dried and reduced to a very fine powder. The dry powder is called a raw meal, further blended and corrected for its right composition and mixed by means of compressed air. When the gas is filled under high compressed pressure, so gas behave like a liquid and convert into a liquid form. The aerated powder tends to almost behave like a liquid, and within half, half an hour the material is blended and uniform mixture is obtained. Then slurry is sent to a rotary kiln. Rotary kiln is a very important component of cement factory. It is a thick steel cylinder of about diameter 3 to 8 meters and 30 to 200 meter long, lined with refractory materials and mounted on a roller bearing and capable of rotating about its own axis at a specified speed. The rotation of rotary kiln causes flakes, that is small clinker particles, to move from upper end to lower end of the kiln and subjecting itself to high temperature, and then kiln is fired from a lower end. In a kiln at a temperature of about 1300 degrees Celsius to 1500 degrees Celsius, at which the material sinters and fuses to form a nodular shaped clinker. Then clinker drops into a rotary cooler where it is cooled under controlled condition. The cooled clinker is then ground into a ball mill with addition of about 2 to 3% of gypsum to prevent flash setting of cement. The setting of cement means immediate hardening of cement after addition of water. The particles are crushed into a required fineness and taken to a storage silos from where the cement is bagged for supply. This is how cement is manufactured according to dry process. Next process of manufacturing of cement is wet process. In wet process, the calcareous and argillaceous materials first crushed to a small fragments, then it is taken to a ball or tube mill where it is crushed to very fine powder and made a slurry of creamy consistency with addition of about 35 to 50% of water. Then slurry is a liquid of creamy consistency and composition of slurry is tested and slurries blend from different storage tanks and corrected slurry is stored into a final storage tank. Then the slurry is spread into a rotary kiln and further process is same like dry process of cement. The next point is constituents or ingredients of cement. The raw materials used for manufacture of cement mainly consist of silica, lime and aluminum, and iron oxide, sulfur trioxide and other alkalis also present but in very small proportions. The relative proportions of these constituents are responsible for affecting the various properties of cement. The chief chemical ingredients of their proportions in any ordinary Portland cement are given. Let's see. There are 8 constituents. First constituent is lime and its formula is CaO and its percentage in all gradient is 60 to 67%. The second constituent is silica and its formula is SiO2 and its percentage is 17 to 25%. The third constituent is iron oxide or ferrous oxide. Its formula is Fe2O3 and its percentage is 0.5 to 0.6%. The fourth ingredient is alumina. Its formula is Al2O3 and its percentage is 3 to 8%. The fifth constituent is gypsum or calcium sulfate. Its formula is CaSO4 and its percentage is 3 to 4%. The sixth constituent is magnesium oxide. Its formula is MgO and its percentage is 0.1 to 4%. The seventh constituent is sulfur trioxide. Its formula is SO3 and its percentage is 1 to 3%. And last eighth constituent is alkalis such as soda and potash. Its formula is Na2O K2O and its percentage is 0.1 to 1%. These are the chemical constituents of cement. Then we will see the function of constituents of ingredients of cement. Constituent is lime and its function is this is main ingredient of cement. Its percentage being about 60 to 67% of total ingredients. Proper percentage of lime which impart cementing that is binding property and it should be maintained. And its effect deficiency of lime causes decrease in the strength of cement. If quantity of lime less or absence of lime in cement, then strength of cement may be poor. The excess free lime causes unnecessary expansion and disintegration of cement. There may be chances of increase in volume after hardening of cement as well as it may broken into pieces means disintegration of cement will happen. One constituent is silica. Its function during the manufacturing process of cement, silica undergoes chemical reaction with calcium to form dicalcium and tricalcium silicate, which are responsible for imparting the strength of cement. It means silica responsible for gaining strength of cement. Its effect: the excess silica adds strength to the cement, but its setting time is prolonged. Setting means hardening of cement is directly proportional to gaining strength. If setting time is prolonged or slows down, then strength gaining rate also slows down. Third constituent is alumina. Its function is alumina forms complex compound with silica and calcium to impart setting property to cement. It means alumina is responsible for hardening of cement. Its effect: larger quantity alumina weakens the setting but weakens the cement. It means if setting time is less, then heat of hydration rate is also more. Because of high heat of hydration, it may lead to a crack. If cracks are occurred on a surface of concrete, then ultimately which is responsible for weakens the strength of cement. Constituent is iron oxide and its function. The ingredient is mainly responsible to impart color to cement and also help in adding strength and hardness to cement to a certain extent. The fifth constituent is sulfur trioxide and its function. Excess quantity of sulfur trioxide also makes the cement unsound. Unsoundness means there may be chances of increase in volume after the hardening of concrete. Next constituent of cement is magnesium oxide and its function. Magnesium oxide, that is magnesia, also imparts strength to the cement when mixed in a small quantity. The magnesium content shall not exceed 5% by mass, and its effect: excess magnesium makes the cement unsound. The seventh constituent is alkalis. Its function: large quantity of alkalis, that is sodium and potassium oxides, are carried away by flow during clinkering. At the time of clinkering formation, alkalis are present in gaseous form and they are carried away by chimneys from kiln. However, a small quantity is left behind and excess of which causes efflorescence. Efflorescence means whitish colored powder deposition of salts on the concrete surface. The eighth constituent is gypsum and its function. During grinding process, a small quantity of gypsum is added. It plays vital role in controlling the rate of hydration of cement. It controls the setting time so that there will be sufficient time for transporting and placing of concrete or mortar for which cement is used. These are chemical constituents of cement, their functions and effect on the properties of cement.